The idea of exploring the universe and traveling among the stars has fascinated humanity for centuries. From the first astronomical observations to modern space launches, our desire to discover the unknown has been the driving force behind scientific and technological progress. However, if we want to reach distant worlds and even explore other star systems, we must overcome a fundamental obstacle: space propulsion. Current technologies, primarily based on chemical rockets, are limited in terms of efficiency and autonomy. Fortunately, in recent years, scientists have developed and theorized revolutionary new solutions that could radically transform the way we travel through space. Humanity has always dreamed of traveling among the stars, but one of the biggest challenges it faces is space propulsion. Traditional propulsion methods, such as chemical rockets, are limited in terms of efficiency and their ability to propel spacecraft over long periods. However, in recent years, research and development of new advanced propulsion systems have been opening new frontiers for space exploration. Among the most promising technologies is electric propulsion, which uses electric or magnetic fields to accelerate gas particles and generate thrust. This method consumes less propellant than chemical rockets and enables long-duration missions. Ion engines work by ionizing a gas, such as xenon, and accelerating the ions using electric fields. NASA has already used these engines on missions like Deep Space One and Dawn, demonstrating their efficiency in propelling spacecraft over long distances. Similar to ion engines, plasma engines use plasma as the propellant. An example is the VASIMA, Variable Specific Impulse Magnetoplasma Rocket, engine, which could significantly reduce travel times to Mars, enabling safer and faster human missions. Another revolutionary technology is nuclear propulsion, which can be divided into two main categories. Nuclear thermal propulsion, NTP, uses a nuclear reactor to heat a gas like hydrogen, expelling it at high velocity to generate thrust, potentially cutting travel times to Mars by half compared to chemical rockets. Nuclear electric propulsion, NEP, converts nuclear energy into electricity to power ion or plasma engines, ensuring continuous thrust and greater efficiency in the long run. Beyond Mars, nuclear propulsion could enable faster and safer missions to the moons of Jupiter and Saturn, allowing humans to explore the solar system with greater autonomy. Nuclear fusion and antimatter represent the most ambitious and futuristic technologies for space propulsion. If an efficient fusion reactor could be built, it could provide enormous amounts of energy for interplanetary and even interstellar travel. Antimatter propulsion, on the other hand, exploits the annihilation between matter and antimatter to produce extraordinary energy, and although it is still far from realization, this technology could make travel beyond the solar system possible. However, one of the biggest obstacles to this technology is the production and containment of antimatter, which today occurs only in extremely small quantities in particle physics laboratories. Moreover, the development of fusion-based propulsion systems depends on the ability to generate self-sustaining fusion reactions, which still represents a significant engineering challenge. Another innovative concept is the use of light for propulsion. Solar sails harness the pressure of solar radiation to propel space probes. A groundbreaking project is Breakthrough Starshot, which envisions using lasers to accelerate tiny probes to 20% of the speed of light, enabling interstellar travel in just a few decades. Magnetic sails, which use the solar wind, are also a possible alternative for propelling lightweight probes within the solar system and beyond. Recently, propulsion technologies based on advanced theoretical physics concepts have also been under development, such as the warp drive inspired by the Alcubierre drive, which hypothesizes the use of negative energy to compress space-time in front of a spacecraft and expand it behind, creating a kind of bubble that would allow travel faster than light without violating the laws of relativity. Another theory concerns the possibility of exploiting wormholes, hypothetical space tunnels that could connect two distant points in the universe, allowing immense distances to be covered in reduced time. These concepts, while still purely theoretical, stimulate research into new forms of energy and exotic materials that could make interstellar travel possible. Another intriguing approach is propulsion based on dark matter or dark energy, two cosmic phenomena that are still poorly understood but constitute the majority of the universe's mass and energy. If science could manipulate these forces, we might witness a true revolution in space travel, opening up scenarios that are unimaginable today. Some scientists are also exploring the possibility of extracting energy from the quantum vacuum, leveraging the principle of quantum fluctuations to generate thrust without the use of conventional fuel. The future of space propulsion is exciting and promising. While electric and nuclear propulsion are already in advanced stages of development, technologies such as fusion, antimatter, and warp travel could revolutionize space exploration in the coming centuries. If humanity wants to become an interplanetary and interstellar civilization, innovation in propulsion will be the key to overcoming the vast distances of the cosmos and making missions possible that today seem to belong only to science fiction. The coming decades will be crucial in determining whether these dreams can become reality and whether technology will be able to push us beyond the boundaries of our solar system. Humanity may be on the verge of an unprecedented era of exploration, where interstellar travel, once confined to science fiction, could become a concrete reality, opening the door to a new chapter of our existence among the stars. Thank you for following this deep dive into space propulsion. If you enjoyed it, leave a like, comment with your thoughts, and subscribe to the channel so you don't miss upcoming videos on the universe and technology. Your support is essential to continue producing quality content.